Good afternoon, everybody. Today we start with the first of the two seminars of Professor Müge Akin from AGU of Kayseri University in Turkey. Professor Müge studied in geological engineering from Ankara University. And then she was in the Middle East Technical University. She also has, during her study, a Fulbright visiting scholar in the United States with Professor Kramer, that is well known for geotechnical earthquake engineering. So we have a couple of seminars today, one on the introduction to liquefaction and post-liquefaction effects, and tomorrow is a case study from Turkey earthquakes. So I think you can start, and yeah, it is good okay. For the audience online. Okay, so I can cover this. Okay, so let me see. So you see this slide, and then there you have the biggest. Okay. Okay. Okay, thank you. So just pushing, you can change.
So sorry, I have to sit because of the Teams seminar. But firstly, I would like to appreciate Professor Amaroso. She's having me in your university as an Erasmus staff. And then we will be having maybe continuing mobility more in the following months or years. It's a good opportunity to have you and then to meet with you in the seminar. Today, I'm going to talk about liquefaction, but before that, I would like to give some information about our university. And for the Erasmus students mobility, there will be some opportunities for the students. Therefore, I would like to give some brief introduction for our university. So it's called Abdullah Gül University. It is one of the previous president of Turkey, and he's from Kayseri. That's why he gave his name to the university, actually. As you know, Turkey is in between Asia and Europe, and we have some touristic attractions and some places. I don't know how many of you have been to in Turkey, but there are some rich cultures, some gastronomy, and some similar tests we have. So in general, when we have a look into our map, here you can see, I don't know if you can follow the mouse. No. From here. Okay. Yeah. So maybe I should take it for the following presentation. In here, go ahead. As you can see, we are very closer to the Cappadocia area, which takes place Erciyes Mountain. And if you like skiing, we are very closer to that area as a Kayseri. Okay, thank you. And here you can see some important cities from Turkey. It's a stage and trade center within the Silk Road, and this is the city center of the area. You can see some historical places and then visit, and there are some additional interests that you are willing to visit. In Kayseri, you can have the option, and even skiing, and we have some similar places like Cappadocia. But even you can easily reach the Cappadocia region to visit some special places and some special hotels, especially in that region. And we have some churches, very, very ancient and very famous ones, actually. And you can have some balloon tours as well in order to see the all around. And for Kayseri, we have some Ottoman and some Selçuk Empire ancient buildings. If you are willing to visit, you can go there. And the important point would be the gastronomy. Everybody likes that. And we have some special taste, including some kind of special meat you can also easily have. And then it's very famous, especially Kayseri, with the which is called pastırma, kind of a dried meat that we are having too much, or probably you will love it. So for our university, as I told you, it's one of the previous president we have, and actually we have a story of our building because we have renovated the factory. That's why it's really worthy to, I would like to share and then worthy the photos. And there are some visions and missions according to our university. If I am going a little bit faster, it's a kind of new generation university. We are actually dealing with some interdisciplinary program, and we are actually considering in connection between the different disciplines. And 100% English education we are having for all the departments that I have to also mention. And here you can see some of the buildings, and it is actually there's a price that they had because of the renovation of this steel building. This is our main and rectorate building. And let me share some of the campus photos, but I don't know if I can open it because of the pointer or the other stage. Here you will see some photos before and after stage of our university, because architects really worked on that area in order to actually preserve the area, which is really ancient and important for us. I don't know if we can reach this.
Yes.
And in our campus, as you can see, this is the big image. Well, no.
Sorry, we have to go out from the presentation.
Sorry. So
Okay.
I don't know how to do that.
Don't worry.
Right now.
Okay, so now it should work. Let's see.
Yeah.
Okay.
Okay. Here you can see our building within the main campus. It's a good place, and I would like to share the main building that was earlier as before, and then after renovation we have some places especially for students or for the people who would like to be there, or we are actually preserving some trees, some special trees, and then in order to have this let's say structure. And we have also keep some of the previous, they are all warehouse, and we are now having classroom buildings inside the offices and etc. And here you can see the renovated part of the facades. And before and after, now we are actually reusing, and then there's a sustainable version of our campus where we can say this is the fire or some office buildings with the renovation in that region, and then we are also still using as an office in here, for instance. And we have newly constructed some buildings like fitness centers and some laboratory buildings. And as you can see nowadays, we are actually dealing with this factory. This is the main factory building, and now they are all covering the columns with some geotextile material in order to again reinforce the structure. Maybe we should say that. So after giving this information, I have to return to my presentation. Hopefully I can reach my page. So with the numbers that I have to say, in general, we have a limited number, which is called kind of a boutique university. I don't know how staff member or faculty member you have, but it's a very limited one. And we have 20 programs, and with the 5 faculties, including 100% English taught courses. And you can see different nationalities. We have even from Italy in our campus. And here you can see our departments. These are the actually departments that we are having so far. And we are not planning to open any medicine or medical faculties. Depending on the technical issue, we are all focusing on that. And from our civil engineering department, we are limited staff in there, and then we don't have any master program. We have a different master program, Sustainable Urban Infrastructure Engineering, which combines all of the, again, urban planners or other disciplines in order to have a program. Especially there are some examples in UK similar to that. And here you can see the other actually programs that we are having. And we are actually having some global challenges. We have some special lessons, including Global Challenge, GLB courses. All students are mandatory to take these courses in 3 years period of time in order to have an idea about some entrepreneurship or even with the sustainability part. And the other things is really critical depending on GLB core curriculum we have. And we are having some, especially for student satisfaction, they are really like our university. And we have some research centers. And mainly we are focusing on, especially for the bioengineering part, like new materials, biomaterials, and etc. I should also add them to you. And we have additional places like Youth Factory, which also supports the students, especially for their needs or for their additional things. It's a kind of new maybe term for all students for us. And here you can see some of the examples from our dormitories. These are also newly furnished, but they were the places who sit the people who worked in the factory as before. Nowadays, they are using as a dormitory. So, yeah, there are some additional activities that I might say, and we have some partners actually, and you are one of the partner. And I would like to share just a short video for our showing university, but probably I need to change it. It's a very short video I would like to share with you.
Almost a few seconds. Back to the screen.
So this is the short video of our campus, and there are additional ones. Probably they will continue, but okay. So afterwards, I would like to give information again related with our department before we start our case, actually. I don't know if I need to share or do something. No, it's okay. Okay. So in our campus, as I've told you, we are the 100 English education, and for our civil engineering program, we have a program 3.5-year program. After 1 semester, they are having workplace experiments. They are going to the firm and then having their experiment at that stage. I don't know how it works in your departments, but it's a kind of different stage because the interners can have the job after finishing their internship. So that would be the good opportunity for them. And what else we are having? We are actually considering applied education. We are focusing on you should play and learn. How can you do that? with making some models or having some special apparatus in order you to have to make your models. We are really considering that. And we have some limited professors. Burak is dealing with material science, for instance. Nimet Hoca is working on the sustainable issue. And other staff, Cihan Hoca is also deals with the earthquake engineering and structural dynamics in somehow, and he's also having a project regarding to the wind turbines. Actually, now he's working on the material that they are dealing with. And I hope you know me, let's say. And the other stuff from hydrology, he's dealing with the fluid structure interaction, especially. We have another professor. I have also met with him in Pavia. I have been to Pavia, by the way. And he's now working in the earthquake engineering and structural mechanics. And another professor from structural mechanics part, and with the railway transportation and the geotechnics, there's another colleague that I have, Halil Ibrahim Hoca. And we have some part-time faculty members for project management and etc. And these are the faculty members. They are also dealing with generally earthquake engineering and structural engineering. We have some laboratory conditions for geotechnics, for hydromechanics, material of construction, structural and transportation labs. We have newly equipped, but unfortunately, as I told Professor Amarosa, we don't have any technician. Therefore, we need to have and improve some of the things by the help of him or her. And for the active learning, as you can see, we have some special Legos. I don't know if you heard about it, Pasco, which is named, and you have the pins, and then you can make your model having this experiment, and then with a shaking table, you can understand the structure, behavior, or even you can prepare a bridge, and then you can apply some train or car load, etc. And even they are going for railway engineering and railway design in order to learn the stage for how it occurs for the railway stage. And here you can see some of the examples for completing at that stage, but I have forgot to update some of it. But for the structural health monitoring or some material science, you can find different options and different projects that we have already completed. And I was also involving a project which is related with the economic effects of the natural hazards related with the Disaster and Emergency Management Authority. I have completed that, but it's also another area that maybe we should also discuss about it. And for our case, we have some undergrad courses. If you are willing to interest, I can give the more details of it. And there are some options, especially for the technical courses. Did I do anything wrong? Or should I pass?
Yeah. Now it's working.
Yeah.
Okay.
So for the program Sustainable Urban Infrastructure, I can give again brief information after the maybe presentation. So thank you for listening me for our university and for our department. So if you wish, if you are ready, we can start with the liquefaction part. I don't know if it will work or...
They can see the presentation. I don't know what happened with the connection with the screen.
So,
the third one, so I can close this.
Yeah.
Okay,
I
now
hope
it
it
looks
will
it's working.
Really?
If you want for this to put again the No, che cosa? Adesso sì, funziona da casa. Okay, so now
I have the laser.
yeah, you have the laser.
So I would like to give brief information about liquefaction. You have already learned also teaching about the liquefaction, but I would like to during that presentation maybe aware of you what exactly we've done so far, and then what should we do? Maybe we can focus on that, or you will be having some questions. In the end, I have some, because we can find some projects or some things to establish during that period, because many things were actually performed during that stage. So for today's part, I'm going to divide the presentation into two parts. Firstly, I will give some examples, some approach for the liquefaction part, and I will be talking about for the post-liquefaction or secondary effects of the liquefaction after happens, what exactly we will be working on, or what do we need in exactly for the following projects. So as you know, soil liquefaction, the term is used after Niigata earthquake. So maybe earlier than that, they have an option to had the experiment, but after having this earthquake with the fatalities, especially for the structural behavior of the soil behavior, it comes to the literature, let's say. So at the first stage, they evaluate and then they find the triggering mechanisms or maybe baby steps. Afterwards, some methods were established, like laboratory or in situ test, and some even nonlinear models. They are using finite element techniques or finite difference. And then it comes out with the liquefaction risk and the mitigation techniques. So we have to consider the consequences of liquefaction triggering in terms of deformation, displacements, or damage. With an addition, there are some large cyclic laboratory testing approaches. In different countries, in different places, they are all dealing with the liquefaction, as far as I can see. And within that sense, they are modeling them with a full scale. Afterwards, they are trying to develop some site-specific theories or empirical formulas. This is the maybe general view that's for the introduction to liquefaction. As we all know, during earthquake shaking, we have loose saturated sand. We have already learned or taught like that, but it is different nowadays because there are some additional works or research, including silty material or even gravelly material. So there are some new updates we need to also discuss about it. And what else? Within the behavior, it's getting denser or reconfiguring the particles. So there should be a water inside the system. So you have to be sure if it is saturated or not saturated. I'm going to give the all parameters. And then water pressure will build up. What happens afterwards? We are trying to all solve the mechanisms or model these mechanisms. So this is the maybe important case for us during the historical Niigata earthquake. So here you can see some of the examples with a magnitude 7.5. As you can see, very limited death or people were died, but lots of injuries because of the structural behavior. And largest infrastructure behavior damage that occurred after this event. So in general, I have tried to find a way or definition for the liquefaction. It's really hard to find and then have this, but I have taken this directly from a web page, including what if it happens or behaves like a liquid. We are all learning like that. So you can have earthquake shaking within the loose material, and then what else? Within the reconfiguration of the particles, there will be a quick behavior we have to also consider. And do you have enough time to move the water from the system, or we don't know actually. Even we are having some observations. And what else I should say? This is that I have mentioned. So there are additional ones, and what is liquefaction or when does it occur? Depending on the, again, earthquake shaking can cause the pore pressure level change. You'll be having increments, especially.
No, è attivo.
Okay, Sarah?
Yes, yes, it's fine. Lo distacco questo.
I can do. Okay. As we all know, eventually the soil begins to behave like a liquid rather than the solid. So this is the behavior that we are having. So where exactly it occurs depending on the especially shaking activity. So you can have blasting even instead of having earthquake event. There would be some increment in the water pressure, and then there would be construction related activities like the blasting you can have, and then you can increase the water pressure at that sense. And also Kramer mentioned that if you have a saturated sandy layer under loose soil conditions, you can have the liquefaction with a magnitude greater than 5.0. So this is another thing we need to consider. And what else typically occurs in saturated loose sands and under dynamic loading, and it all affects, especially like this, river areas or lakes, some bodies that you can have very closer to the water regions. So how it occurs depending on the structure, if they loosely packed, so that means that it's getting to denser configuration. Actually, one of our professors saying that you can have the material like concrete or steel, there are some standards for it, but for soil, it is impossible to have this because it's very getting complicated, and it is case study based events that you can have. And during the earthquake, what happens? There will be enough time to water in the pores of the soil to be squeezed out, and then there will be some trapped and prevents the soil particles from moving closer together. That means that accompanying with an increment in water pressure that we can say in the system. So here you can see their softening and weakening of the soil deposit behavior. And afterwards, what are the methods or how we collect the data depending on the assessment of liquefaction triggering? Lots of publications you can find depending on like field penetration testing or some field-based methods or even laboratory testing methods. I'm going to give some examples from them, and I will try to just emphasize and aware of the maybe importance of the liquefaction. Here you can see the typical maybe approach that we are having, some empirical analysis. You can have liquefied, liquefable layer, and you can have some borehole logs within SPT, standard penetration test application, or you can have CPT. As far as I can talk to Professor Amoroso, there are some new techniques that you are having in Italy, as far as I can see. But in general, the basic trend and the economical one using SPT all the time. I don't know, you are also allowing all the companies to apply SPT at this stage. But there are lots of correlations, and you need to also consider different items that I'm going to also show you. So this is the maybe main approach for us. What else we are having? We are having within the field penetration testing, we need to look for factor of safety. We have cyclic resistance ratio and we have cyclic stress ratio, as you know. We are obtaining them with different parameters, with different factors in order to reduce or increase or change the level that we are having all the soils so far. So in general, at the beginning, we have started with SPT or other tests for the cyclic resistance ratio. With the cyclic stress ratio, it is the representation of liquefaction demanding imposed by the earthquake. And here you can see their explanation within the general sense. But within this CSR, here you can see some RD coefficient that you can obtain a formula that also related with the Chettin's approach. Or you can have some corrections within the SPT and value. And then you can have some graphs, as you all know, depending on that. when we correct and we had the factor of safety result, depending on magnitude scaling factor, or even you are having some additional items or corrections that you need to consider for the fine content. There was a Chinese criteria, as you all remember, but it is useless right now. So there are lots of updates that depends on the fine content even. So as far as I can have the talk from Çetin and Bilge just recently, they are assuming that the road connection that we are having, for instance, for CR, it looks like should be updated. We are considering that we are taking the road and then having the application for the correction. Or they are also thinking that energy ratio of the SPT. So there are some unknowns, and still we need to find out for the corrections or for the applications of the formula. Because in Italy, how many percentages of energy ratio you are using for SPT? Is it 60? Yeah, okay. Okay, but
you went to the beginning when buy the machine, but then the main always the same number, and probably should be checking the.
There are some actually apparatus in order to measure the energy correction, so it is necessary to apply maybe in instead of having this item. So SPT, again, you can find many correction factors with the fine content. There would be some applicable range at different, procedures and some empirical formulas. And it continues. Why? Because we have overburden correction factor. Even you can add some sloping ground correction factor. So if it is sloping area, so you have to consider additional correction. It looks like getting complicated with the SPT based or even CPT based. I have just taken recently as a CPT study, you are all familiar with the cone penetration testing. They have performed within the critical layer, which is related with the gravelly soils. So here comes to our mind that gravelly soils you have, and you are dealing with some CPT applications in order to get the liquefaction analysis or etc. It's a kind of approach from New Zealand. And I have also come across DPT for the Ecuador. I don't know how you're familiar with. It is called Chinese Dynamic Penetration Test. They have also compared with, again, in gravelly soil in order to get some results for the liquefable layer for the critical area. So there are still ongoing projects and new maybe updates for the applications. And when we come through the shear wave velocity approach, there are some especially the famous one, Anders and Stoke, that we are using it a lot. But there are some, again, gaps or some new updates that I have to mention, that I'm going to show some figures and some recent references. And within the returning SPT data, you can have from different areas. When you have a look with the different states and with different years, we are actually having more data. That means that you can be in the safe side and you can be sure in order to study. But how about CPT, for instance? Again, it is valid. You can have different approach within the Idris and Boulange, for instance. They are increasing the database again, and then having different curves in order to be sure which would be the liquefied and non-liquefied site. But in somehow there are some researchers even could not update themselves or could not use the recent version of the methodologies. Even they are maybe losing themselves inside the research or other things. So this is another critical issue. We need to clarify all of the items. And for the VS calculations, as I mentioned, we have Understock, it's very famous, and there's a new study with Cayenne, which is also related with the shear wave velocity, depending on the different cases. So if you have the data, you can even try, or you can compare with SPT, VS, or CPT, etc. But when I arrived and we talked a lot with Professor Amarosa about SDMT, there are some still works ongoing at that stage, and it is really worthy to work on it. It's also, there will be some comparison in between the CPT and SDMT, and she showed me and shared with me some of the important items. This is also important and critical thing for the liquefaction behavior and for obtaining and updating the cases, maybe I should say. These are the calculations part, but how about databases? For instance, I would like to share a database from Italy. They have 120 cases, or even some special cases that they are collecting as a sand boil or some lateral spreading or liquefaction behavior. But when we think about the worldwide stage, that means that you need to also criticize the effect of the database that we are having. Nowadays, maybe you heard that attenuation models, like the new generation attenuation models, that's also the new generation of new databases depending on next generation liquefaction database. I have searched a lot, but there are still some missing data that you need to also update for all over the world. And in some sense, the data expansion depends on the quality of the data. Another issue that you need to consider. There are actually a group of Professor Kramer that also involves in, and generally having some meetings depending on this NGL database. Maybe there should be some additional references we need to add, and then we need to talk about it. So until that stage, we have already calculated, we had the database, and what happens, or what if we have the different parameters like geology, topography, or some hydrological conditions, or what else, some regional setting. So the seismicity would be critical for us, and some field and laboratory investigation, they should fit pretty well, and some geotechnical profile. And here you can see very recent data. They have calculated the settlement in that region, but they have measured different settlement depending on liquefaction base. So that means that you are calculating, but you have to also confirm that if it works at the field or not. We have to be sure. That's another item that I need to mention. So what else for the geology? When we return to our case, yeah, we are all knowing that sand or some silt, but how about clay material or gravelly material? There are still some unknowns, and there are still works ongoing at that stage. With the factors, we need to also consider the positional environment, or even age, or the magnitude. So we have to divide, or maybe we have to look for some special parameters in order to connect the database. So here you can see the effect of the geology, or related with the behavior that it may occur after a liquefaction, or even in these areas. Or you can see the structural behavior, but the foundation, because of the liquefaction, that may cause the problem for your case. So for the geology, especially geological structures and faults, type of the sediment, we have to also go deep inside the area, because age of sediments would be also critical for us. I don't know how size, or I mean the scale effect would be effective. We need to have a local size, local scale, or we need to make it bigger size. So we have to be sure again. And of course, degree of consolidation, depending on the clay material you have, or past stress history, how we can measure or how we can understand that. So we need to have some geotechnical profile or site investigation models in general, and of course 3D one right now. So as you can see, some alluvial material here you can have. And what else? Amplification. So do we need to consider both amplification and liquefaction at the same time? Yeah, maybe. But we should also work and then think about it, because it's also related with the topographic activity. We should also consider that. I would like to emphasize. Besides, there are some hydrological conditions. So how we can measure the depth of the groundwater table, or how can we be sure that the depth is exact depth for us for our analysis? We are assuming some kind of behavior that occurs in the actually soil type. So it depends the rains or drainage pattern, etc. So you need to have a whole model, including maybe interdisciplinary approach. And when we consider the effect, especially in the moisture conditions, like flooding or groundwater flow regime, you will be facing maybe liquefaction behavior that may occur just frequently. I have a study that I would like to emphasize that occurred in Washington State with a very low seismic activity, but there are lots of actually liquefaction behavior observed within this range. So we have to consider again the magnitude, or which magnitude levels that we can have, which amount of accumulation or liquefaction that we can have. Another maybe point that I have to be, give information or a value. So for the seismicity, again, we have some potential. It's a nice, actually, figure, including all of the items, but we need to also deal with the below layers that we are having, how we can be sure that there will be a boundary in between the layer, or depending on the fault activity or some past earthquake or tsunami history, or etc. So there would be a kind of site-specific seismic hazard analysis should be done for the relation of the parameters and the performance. Sorry. I hope I don't get bored you, but yeah, it's a long topic. So if we solve or find the parameters, but I can add additional ones like the factors. Can I add instead of magnitude, like intensity or duration of the earthquake? Yeah, there might be possibilities. So it also affects the liquefaction behavior. Again, it's related with the groundwater, and the other things also similar. But besides, we should also have in situ confining pressure that occurs around the material. And these are the maybe we should consider, especially intensity and duration. We have to make somehow correlations in between them, maybe. Or like the presence of water that I am repeating. So how we can do that? I searched some of the approaches. There are some flow charts. Okay, you can take one of it, for instance. It's a very recent one. And they have two phases, for instance. And with this, they have the data they are collecting with the survey, and then having field survey, and then some finding for liquefaction manifestations in the area. It's really hard how we can behave for a flow chart, or do we need to have our for each country or for each area? We should be sure. And what else? This is another flow chart, for instance. You have the soil type, and here you can see with the differences and the behavior of flow liquefaction or some cyclic mobility or softening behavior. Which case or which point should I use and then complete the behavior for all general liquefaction approach? This is another item that I have to also give this to you. I found another flow chart which is related with the liquefaction triggering assessment. So how I can assess, or how I can define the liquefaction depending on the methods, actually. You can have the different soil profile. I don't know how it's clear, but it's a recent work of, again, Çetin et al. And you can have different steps by including like the even such response analysis in the system. So which flow chart should I use? Or which methodology should I take? So this another question. So until that stage, I have tried to figure out and then give some questions or just brainstorming for the liquefaction part. If you are not get bored, I'm going to continue with the post-liquefaction part. Or if you don't have any questions. No, it is fine. Sorry, my voice is getting maybe sometimes stable because of talking. Yeah. Yeah, actually, I heard from their approach, especially depending on the methodology that they are having working on probably.
Okay.
Yeah. So we need to be updated all the time, and then it's really hard while you are doing your work, and then you need to yeah.
Big change.
Big change. Yeah.
Yeah. So important.
Yeah, especially for the road length also.
Yeah.
It's also yeah, critical.
Critical. Short length is like 1 meter or less than 1 meter.
Less than, or it depends. How can we be sure the firms are applying the exact amount of the road, or are they giving the exact length of the road? Yeah. So I'm going to continue with the post-liquefaction effects. In here, you will see some secondary maybe moments that occurs after liquefaction, such as you know, sand boilings. It's a very nice case for us. And there are some settlements, some lateral spreadings, and some ground oscillations, some slope failures that may occur, and what else? Some damage in the various structures. So besides that, we can have some effects on the structures, like the bearing capacity loss that we can have, or some differential settlements, or some increments in the pressure of the retaining walls, or some buried objects like floating inside especially the pipelines, maybe the main problem that we can have because of the liquefaction failure. And I would like to share these foundation failures. They're all really famous after 1999 Kocaeli earthquake, as you can see. The structures are seems okay depending on that stage, but the liquefaction behavior, or even in here, as you can see, with a settlement of 35 centimeter or maybe more than that, they have had this problem. 1999 earthquake, or with this, as you can see. So these are the foundation failures. What else? You can have liquefaction induced settlement and of course lateral spreading. So as you can see, the hotel moves towards to the lake because of the lateral spreading behavior. It's a huge and important case for our, even in geotechnical history, maybe I should say that there are some approaches for it. And what else? There are some lateral spreading that you can observe, especially near the river, and then you need to also measure, and then you need to go after the earthquake in order to get the data. But it's another thing that we need to consider. Additionally, sand boilings. How would be the amount of the sand boilings, or what would be the radius that you are having, or the material that comes out? Also, we should add the cap soil behavior. You can have maybe unknown material that does not allow to material goes up. So we have to also study on that. And with the sand boilings, you know, Christchurch is the typical one, and Professor Amoroso is really worked there, as far as I can see, collecting and making lots of experiments. It's a nice, I think, laboratory in nature to have an idea, especially the sand boilings material. Besides, as you can see, with the damage in the various structures, within Kobe or again Christchurch, and even some sinkholes that may occur within the whole amount of the material that is the behavior of the liquefaction related. Sorry, I couldn't give some of the important items because I have to keep them for tomorrow. Therefore, I need to maybe just give the general idea that we are gonna have. And again, from another view of the lateral spreading, there is also related with the 1999 earthquake. And here you can see the displacements in the park or within the region that occurred in that area. So, for the effects, as I've told you, we have a liquefied zone. It spreads, and then there are some moments that occurs with the lateral translation that I might say in that sense. And you can see some schematic examples. While I am putting these examples, I realized that we are theoretically perfect. We can draw everything, but while we are having the experiment or the other things, it's really changed. We cannot see the theoretical parts in the field. And even with the other type of the behavior, with the vertical displacements, and here you can see the different behavior that occurs, especially in this sense with the lateral spreading or some bearing failure with the actually depending on the foundation settlement. And here you can see after 2008 Ventian earthquake, there are some hand boils that comes from a structure. So we need to also consider that there will be a kind of differential settlement, or there will be some problems that may occur in the structures, liquefaction-induced problems. Another case, maybe we should work with the structural engineer. And with the, again, differential settlement, it is not catastrophic, but as you can see, there are some adjacent behavior in between the structures. You can observe with the settlement or differential behavior that occurs in the structures. What else? I should say, okay, there are some approaches. We are making some maps. So how we can decide the map is necessary, or how would be the scale of it, or we should be sure about the details. Here you can see from Kuberdansky, they have actually studied some places depending on the liquefaction mapping or liquefaction, not the triggering, but you have to also consider the hazard index or the size of the liquefaction potential or severity. So it's another issue that I have to say. In here, I really like this when I'm seeing that liquefaction resistance index is a kind of maybe index we should also consider about that, because it's depending on the observation of liquefaction, and here you can see the distribution of each equivalent CRR, and there are some settlement that may occur in these zones. So it's kind of a microzonation or liquefaction based. I mean, maybe the combination all of it. So it's another issue that we need to consider. Or while we are having our microzonation, we need to add liquefaction in that sense with a hazard index. It's a good example. So these are the effects that we have seen, but how we can solve, or how are the methodologies? We have actually settlements. As you know, we have different approaches depending on Tokimatsu and seed, Ishihara and Yoshmin, Shimamoto and seed, and additional databases, additional approach that we are having. I have actually used some of them. By the way, I have studied seismic macrozonation for a specific area. Tomorrow I'm going to talk about it a little bit. I have prepared the vertical settlement depending on different formulas actually. And one of them, here you can see the area, and then depending on the amount of the settlement that may occur with the liquefaction. Or even with the Shimamoto, I have used some approach depending on the graphs and with the other one. But another case, which methodology should I use, or which amount of settlement should I take, or even for the lateral spreading? The newest version or the previous one, or how can I decide? Another issue. And the thing that I have mentioned also, this is the thickness of liquefable layer and overlying non-liquefable soil. Here you can see their approach, and that there are some curves actually depending on liquefaction induced ground damage. Do we need to update this, or are there new updates? Yes. Right. Another thing for the post liquefaction effects actually. And what else with this? Sönmez et al. Modified the Ishihara curves after the 1999 earthquake. And they thought that they have to use, or we have to, liquefaction severity index. And then we should decide the thickness of the cap soil or non-liquefable soil at that stage. This is another item. We need to work on it. There are some still cases because the proposed chart needs to be tested, as I mentioned in the slide. So with the effect of liquefaction induced ground damage before its application. So it's another view. And for the lateral spreading, how we can obtain the results, or which formulas should we use? In here, as you can see, some of the researchers, depending on empirical models that actually deals with the lateral spreading behavior, and maybe we should add in somehow sloping ground or sloping amount for the lateral spreading, as far as I can see, because we are having some corrections for the key K related, as you remember, for SPT, but for liquefaction induced ground deformation, we don't have any sloping behavior, or we need to take into consideration, as far as I can understand. And here you can see one of the approach, and that whole equation I have used. Again, lateral spreading amount in somehow the places next to the river, it's getting higher and complicated. And with the other one, it's related to Kramer and Baska approach. Again, you can see the red areas getting higher or bigger. Why? Because of the approach or because of the cases, as you can see. So there would be some comparison, or we need to decide. And for the another one, Idris and Boulange. It looks like similar to Professor Kramer's approach actually, and Baska, but why it differs too much, or what is the reason that we are having different size of the lateral spreading or even settlement? This is we need to talk maybe. And with a post-liquefaction effect, with the ground deformation, it's also necessary you to have a zonation map. It's from my area again, and there are some limitations for Ishihara method, such as the maximum acceleration that you are having in the system. So this is another thing why we are having acceleration value, or why we are using PJ or magnitude or etc. When I am finding this figure from Pinterest, I asked the Professor Amoroso, it's a very nice to have some boundaries in between them, but how we can decide in the liquefied soil? Okay, you have the lateral spreading. It seems to us very severe or major, but it continues with the land damage with the differential settlement. So maybe we should study both, or at the same time give the similar results in between them. I don't know. So when I am working and having the other approach for the lateral spreading, I realized that Çetin and Bilge divided into them like empirical correlations or integration of the laboratory work that they have or the other researchers have, or some sliding block analysis or even with the computational mechanics based on the application of 2 or 3D numerical model. So in which sense or in which area or which level we should apply these techniques? And these are the latest versions. Even with, again, settlement predictions, we have another approach like Yi or Yoshpin. These are the newly generated curves and the materials that can be adapted for the settlement usage. And what else? We are using some, actually, softwares. I don't know which one is famous in Italy. We have rock science programs, generally Saddle or Slide or etc. Or Geo5, I heard, or even Plaxis. We are using it a lot for modeling in order to have the deformation and the behavior of the soil material. So we have to be careful about the usage of them. So I am about to finishing the slides. I would like to get your feedback, especially some questions about mine, depending on the liquefaction related issues. But before that, I would like to say, last but not least, the input parameters are for liquefaction is really important for us. And what else? Databases are important and it should be widened and standardized. And we need to look for other methods, such as you can see, it's just newly published, depending on, especially for new students or new generation, artificial intelligence models or machine learning, because they are all integrating these systems into our area, as far as I can see. So I hope you enjoyed and then you understood some of the important points that I'm trying to have. And here you can see some, maybe I can say questions, suggestions, or some possible projects. But in this sense, as I've said, we have a database and there should be some paleoliquefaction studies with the combination of all liquefaction. And there would be some standards we should have. Oh, even with the mapping style. You have actually for microzonation, but I don't know how closer to liquefaction related damage you have, or maybe I have to also look for make some research about it. And there should be some 3D liquefaction modeling, and besides some events database, like missing ones, and then before and after liquefaction cases. I try to make it kind of maybe let's say brief, but I would like to also mention the ground improvement techniques. Maybe tomorrow I can add some slides. It's also necessary for you before and after application of the ground improvements, how we can measure them, or do we need to follow the liquefaction behavior before and after cases. In my opinion, in this sense, I would like to give the information and aware you about the important points. So I was wondering your comments and let's say suggestions.